Hello everyone, it's Mr. Salimata over here, and in today's lesson we'll be looking at how to find the gradient of a straight line. And by the end of this lesson, every student should be able to interpret and calculate the gradient of a straight line using the rise, over, run, and the gradient formula. Yes. Now, talking about the gradient, yes, the gradient is the measure of how steep a straight line is. Yes. Okay. So let's look at these four straight lines over here. Yes. So we have this straight line over here. Yes, and another one. Yes, and we have a flat straight line, and we have another line going down like that. Yes, so let's compare these two. Yes, which line do you think is steeper? Yes, so we find that this line over here is steeper than this line over here, right? So this line has what? Has a higher gradient. Yes, and this line over here has what? Has a smaller gradient, right? Now, if you look at this line here and this line over here, they're all going up as you move to the right, right? So both of them have what? Have a positive gradient, but this one has a higher positive gradient, and this one has a what? A smaller or lower positive gradient. Yeah. Okay. So if we look at this flat line over here, yes, it's flat. So our gradient over here will be what? Will be 0, right? And then let's look at this line that's going down over here. Yes, see, it's going what? It's going down. Yes, as you move to the what? Yes, it's going down as you move to the right. Yeah, so that means it has a negative gradient. Yeah. Okay, so now I'm sure you guys are now asking yourselves, all right, so then how do we find the gradient? Yes, how do we find the gradient? Okay, so to find the gradient, yes, to find the gradient, we have to pick any 2 points on the line. Yes, we have to pick any 2 points on the line over here. And then we have to see how much, yes, how much the straight line rises vertically compared to how much it moves or runs horizontally. Yes, and what I mean by that is, from the 2 points that we pick, we have to see how much the graph, yes, of the straight line rises or moves vertically, which is in the y-axis, compared to how much the graph or the straight line moves or runs horizontally, which is what? In our x-axis. Yes. Okay, so let's try to pick 2 points over here. Yes, let's try to pick 2 points. Yes, let's pick 2 points on our straight line graph over here. Yes, so I'll pick this point over here, yes, which is 0, 1, and I'll pick this other point over here, which is 1, 3. Yes. Okay, so now we said we have to see how much the graph rises vertically. Yes, and the y-axis, yes, from the 2 points, yes, between the 2 points over here, right? So that's like 1, 2, yes, so from my point over here, yes, rise, yes, I'll label it over here, rise, yes, how many times? 2, yes, compared to how much it runs or moves horizontally, which is the x-axis, yes, 1. Okay, yes, this one over here is our what? Is our run. And how many times did it move? Once, right? So there we go. What have we just done there? We have found, yes, we have now discovered how we can calculate the gradient using what? Rise over run. Yes. Okay, so that now brings me to writing our rise over run formula over here. Yeah, so this is how we find the gradient. Yes, so if you remember, our rise was what? Our rise was 2, right? And our run was what? Was 1. Yes, and if we divide 1 into 2, what are we going to get? We will get 2. Yes, so this line over here, this straight line over here, has a gradient of what? Of 2, right? Now remember, we did say that the rise, yes, the rise over here is what? Y axis, right? So what then can we say? We can say that it is the change in what? In y, yes? And then the run, we're talking about it, how it runs or moves in the x-axis. So we can say that it is also the change in what? In the x, yes? Change in x, right? And this delta over here is what? Is change. Yes? Change as well, yes? Change in y and change in x, right? So then we are now asking ourselves, what does Mr. Salimata mean by change in y and change in x, right? Now remember, we picked 2 points, right? We picked 2 points, 0, 1 and 1, 3, right? So the change, yes, the change in y is the difference, yes, the difference in y values. And the change in x, yes, is the difference, yes, the difference in x values. Yes? Okay, so do not forget change in y is the rise, change in x is the run, and the change in y is the difference in what? Y values. The change in x is difference in what? In our x values, right? And according to the points that we picked over there, yes, okay, according to the points that we picked over there, allow me to just erase all this, yes, according to the points, yes, that we picked over there, yes, according to our points that we picked, remember, we picked what? 0, 1, and 0, yes, and 0, 1, 3. Yes, 1, 3. And we just said that our, yes, that our what? Our change in y is the difference between what? Between the y values, yes? So this is my x, this is my y, that's my x, that's my y, right? I'll denote this one as my x1, y1, x2, y2, yes? So the change in what? In y, the difference between the y values. So I'll pick my y2 over here, that's 3, yes? The difference, y1, 1, the difference in now x values, x2, which is 1, and the difference is what? My x1, which is 0. And if we calculate that, what do we have? We have 2, yes, 3 minus 1 is 2, 1 minus 0 is 1, equal to 2. Right? Okay, that's good. So then, what then do we conclude? Or rather, what then will be our gradient formula? Yes? So, sometimes you would hear other teachers, or maybe you might read it in a question paper, and they say, find the slope. So, gradient and slope mean the same thing, yeah? And they are denoted by a small letter m, yes? So, we're now talking about y2 minus y1, yes, over x2 minus x1. And this right here is the gradient formula, and this is the formula that you can use to find the gradient of a straight line. Yes? Okay, now remember, you can either, yes, you can either use rise over run, yes, or change in y over change in x, or you can use this formula over here, but in the end, we are all finding one thing, which is the gradient. And if we follow, or rather if we go through what we've just done, you'll find that all these formulas mean the same thing. Yes, and the purpose of these formulas is to what? To find the gradient of a straight line. Yeah. Okay, so let's look at another example. Yes, so we can get a better understanding. Let's take a look at our other example over here. Yes, and as you can see in this example, our straight line is going down. Yes, so then what does that tell us about the gradient? Okay, so that means our gradient will be negative. Yes, and remember, for us to find the gradient of a straight line, we have to pick 2 points on the straight line. Yes, and in this example as well, we are going to use rise over run and change in y over x, and yes, the gradient formula as well. Yes, okay, so before I go any further, just allow me to write my gradient over here, because that's what we want to find, right? So the first one, we shall use rise over run. Yes, and remember we said we have to pick what? 2 points on the line, right? So for me, I'll pick this point over here, which is -1, +3. And then I'll pick this other point right here, which is +2, -3 over there. Yes, okay, so what's our next step? Our next step now, we have to see how much this line over here moves, yes, downwards, yes, or in our y-axis downwards, compared to how much it moves horizontally, which is in our x-axis, yes, to the right. Yeah, so we do that by what? By drawing a triangle over here, yes, connecting the 2 points that we have chosen, right? And to do that, I would advise you use dotted lines. Yes, okay, so I'm just going to join my points like that, yeah, with my dotted lines. Yes, yeah, okay, so now that we have this right triangle over here, so what are we going to do? All we have to do is what? Is we have to now count, yes, how much our straight line moves downwards in our y-axis, and then also have to what? To count how much it moves in our y-axis over here. Yes, okay, so let's do that together. Okay, that's 1, 2, 3, 4, 5, 6. Yes, so in our y-axis, yes, our straight line has gone down 6 times, and if it's going down, that would be what? That would be -6, right? Okay, so now let's see, yeah, let's compare it to how it moves in our x-axis horizontally. Yes, okay, 1, 2, 3, right? So it's moved to the right side in our x-axis how many times? 3 times. That's what? Positive, because it's moving to the right? And if we divide 3 into -6, what does that give us? It gives us what? -2. Yeah, okay, so this is the gradient of that straight line over there. Yes, so let's now use the change in y over the change in x. Yes, and remember we said the change in y is what? Is the difference in what? In y values, yes, from the 2 points. Yes, and the change in x is the difference in what? In x values, yes, from the 2 points that we picked. So to make that easier, I'll just, yes, write the points that I picked over here, yes, for clarity. Yeah, and remember, this is my x, this is my y, this is my x, this is my y over here. I would note this one as my x1, y1, x2, y2, right? Okay, so now, before we even do, go on with the calculations, right? Let's come down to this formula over here, which is the gradient formula, right? The reason why I'm writing this gradient formula over here right now is because what we're going to do with the change in y over the change in x is the same thing that we do with our gradient formula over here, because we are taking the same values, right? And all we have to do is just substitute them in this formula. But let's move on with what? With the change in y over the change in x, yeah? Okay, so y, I'll get my y2 over here, which is -3, the difference, my y1, positive 3, yes. And what do we have there? We shall have what? Negative 6, right? I'll get now my change in x, right? x2 is what? Is 2. The difference, yes, negative 1. That gives me what? That gives me positive 3, yes. And 3 into negative 6 gives me what? Negative 2, yeah. So you see the reason why I wrote my formula over here. This formula over here and this step over here, these are basically the same things, yes. And like I said in the previous example, I said whether you use rise over run, the change in y over the change in x, or you use the gradient or the slope formula, you still are finding the same thing, which is what? Which is the gradient, yes. Okay, so this is where we're going to end in this lesson today, yeah. I hope you guys have learned how to find the gradient of a straight line, yeah. Okay, thank you so much.